Good morning. Here is an example of solving a polynomial inequality. And sometimes these particular problems are a little more difficult. So I want to give us a visual representation of what is happening when we are solving a polynomial inequality. So I have the problem here on the left. It's x plus 2 times x minus 3 times x plus 8. I want to make a note that this is already in factored form. If you run into one of these that's not in factored form, the first thing that you're going to do is you're going to set it equal to 0. And we're not actually setting it equal to 0 because it's an inequality. So you're going to get 0 on one side and you're going to get the polynomial on the left. And then you're going to factor. Okay? So set equal to 0 and factor. That has already been done for us in this particular problem right here. So that's already been done. The second part, which is probably the more difficult part and what students aren't quite sure what to do about, is we have to find our critical numbers. Okay? And in this situation, our critical numbers are our zeros. Okay, so the way that we find that is that we set each one of these factors equal to 0. Then, from those critical numbers, we are going to create intervals and do some test points. So with those intervals, we do the test points. Okay, and then from those test points, we write our answer in interval notation. Okay, now before we do that, and we are going to do that on the next slide, before we do that, I want us to look at this graph right here. Now this graph, I had to, because I really wanted to show the zeros. So I've got x plus 2, x minus 3, and x plus 8. So x plus 2 gives me a 0 of negative 2. Okay, so there's my 0 of negative 2. X minus 3 gives me a 0 of positive 3, and x plus 8 gives me a 0 of negative 8. Now I just set those equal to 0. That's how I got those. So those are my critical values, my critical points. Now this graph continues to go up like this, okay, and then it's got a loop down here, and then it goes all the way to infinity. What we are looking for is when is this graph less than or equal to 0. So when we look at the graph of this, we can actually tell what our answer is going to be. Okay, our answer is going to be all of this area right here that falls under the graph. Now, because that is less than or equal to, that means that this point, and this point are included. Now, if the or equal to wasn't there, then we wouldn't include those. So we can actually look at this and determine what our answer is going to be from the graph. Now, I don't recommend that because you've got to be able to solve it algebraically, but that's what we're doing here, is we're identifying where is this graph less than or equal to 0. And so our first area is dealing with x values on this part of the number line. Okay, so that is going to be represented by negative infinity all the way up to negative 8. Now, negative infinity always has a parentheses. The negative 8 is included because of that or equal to. It's less than or equal to. Okay, then we have to do our union, and we pick it up again right here. Those are our x values. Okay, and let me see, that is negative 2 to positive 3. And that is why we have. So that is our final answer right there. We just looked at it graphically. Okay, so now let's do it algebraically. So it's already been set equal to 0 and factored. Okay, so we are going to start with number 2, finding our critical values. Okay, so in order to find my critical values, I am going to set each one of these factors equal to 0. So I have x plus 2 equals 0, x minus 3 equals 0, and x plus 8 equals 0. Okay, so I have x equals negative 2, x equals positive 3, and x equals negative 8. Now, I think it's pretty important to draw a number line here so that we can figure out our intervals. If you don't draw that number line, sometimes students don't put the intervals in the right order. So it's important to go ahead and put those in a number line so that we absolutely make sure that we are putting them in the right order. So the first one I have is negative 8. So I've got negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Okay, so there's negative 8. Okay, then I've got negative 2, and then I've got positive 3. Now, you've got to do, so these are what we call critical values. Now we've got to set up an interval that includes all of this. So this right here, this area right here is my first interval. So my first interval is going to be negative infinity to negative 8. That's my first interval. Okay, my next interval is negative 8 to negative 2, and we don't need to worry about any the brackets here, because all we're doing is we're finding intervals. We're not deciding on the answer. Okay, then our next one is negative 2 to 3. That's our next interval, negative 2 to 3. Okay, and then our last interval is 3 to infinity. Okay, so I got these intervals by finding my critical values, putting my critical values on the number line. And this is an interval, this is an interval, this is an interval, and this is an interval. Now, we know what is happening at each one of those critical values. We know the behavior of the graph. At each one of those critical values, the graph is crossing the x-axis. So we know the value of that is 0. So we don't want to pick numbers that are already at 0 because we already know what happens to that. So we're going to have test points. Okay, we're going to have test points. These are our intervals. And then we are going to have test points. So my test point has to be a number that's in this interval, negative infinity to negative 9, or negative 8. So my test point is going to be negative 9. So I just need some number in this interval right here, just some number. Negative 8 to negative 2, I just need a test point in that interval. Negative 2 to 3 has my favorite test point, which is 0. And 3 to infinity. 3 to infinity. I wrote 3 to 0, and it needs to be 3 to infinity. Okay, 3 to infinity. I'm just going to pick 4. Okay, now what I am looking for is whether or not when I plug this in, I get a true or I get a false statement. Okay, so I'm going to plug negative 9 in to my original problem. Okay, I'm plugging negative 9 into my original problem, and I want to know when I plug negative 9 in, do I get a true statement or do I get a false statement? Okay, the other thing that I want to remind you is that you are multiplying all of these right here. Okay, so you're multiplying each one of these factors. You're multiplying them. Okay, so I'm putting negative 9 in. So I'm doing the test point for negative 9. Negative 9 plus 2 is negative 7. Negative 9 minus 3 is negative 12. Negative 9 plus positive 8 is negative 1. Now I want you to look at this. All I need to know is the sign, because we're talking about less than or equal to 0. So all I need to know is the sign. So I have a negative number times a negative number, which gives me a positive number. And then I have a positive number times a negative number. So that's going to be negative. So it doesn't matter what negative 7 times negative 12 times negative 1 is, because we're going to get a negative number. And so that's going to make this true right here. Okay, so this interval, negative infinity to negative 8, is true. It's true. Okay, now we're going to plug in negative 3. When I plug in negative 3, I get negative 3 plus 2. That's negative 1. Negative 3 minus 3. Now be careful there. Negative 3 minus 3 is negative 6. Okay, negative 3 plus 8 is positive 5. So here I've got a negative times a negative, which is a positive, times a positive. Okay, so that's going to give me a positive number. All positive numbers are greater than 0. So this is a false interval. Okay, so that is not going to be part of my answer. Now we're going to plug 0 in. 0 plus 2 is 2. 0 minus 3 is negative 3. 0 plus 8 is 8. Okay, I have a positive number times a negative number, which is negative, then negative times positive. So that is going to give me a true statement. So that means that negative 2 to 3 is part of our solution. Okay, in our last one, 4 plus 2 is 6. 4 minus 3 is 1. And 4 plus 8 is 12. All of those are positive. Positive times positive times positive. So it's going to give me a positive number. So this is going to be false. It's going to be false right here. Okay, so what we do now is we go back and we look at where we had true statements. So we had a true statement right here, and we had a true statement right here. So these intervals right here are part of our answer. Okay, now at this point we've got our intervals, but we have to look at this. Do you see how it says less than or equal to? We have to take that into account. Because of the or equal to, we're going to have a bracket here, here, and here because it says or equal to. So my final answer to this is negative infinity to negative 8, union negative 2 to 3. Okay, that's my final answer. And if we go back and we look at the graph, that is exactly what we got when we looked at the graph. Okay?